go ahead and get started. So good afternoon, everyone, and welcome to another webinar of Kent Seminar Spring Series. Today, we have an interesting presentation given by Mary Joyce about the transformation of the mobility industry. Mary Joyce is the Global General Manager and Vice President of New Mobility Underwriters Laboratory. She earned a bachelor's in computer electrical engineering and master's degrees in electrical engineering and business administration, all from Oakland University. We're so glad to have you here today. And before I go on, Professor Alkari, would you like to say a word?
Yeah, I'm very excited to have Mary with us today. I mean, we have been working together in order to help in developing our I-Act, and we're very excited in partnering with her. So, Mary, thank you for being with us today, especially to talk to our students about how is the mobility going. Thank you.
And just a few quick reminders before we start. The presentation is 40 minutes long, followed by 20 minutes of questions and answers. And there are two possible ways you can ask your questions. You can either type them in the chat box and I'll ask them on your behalf at the end of the presentation, or you can simply raise your hand and I'll give you the floor to ask your question yourself. And without any more delays, please, Mary, can you share your screen? And the audience is all yours.
Okay, very good. While I'm sharing my screen, I'll shut my video off just so that it's a little bit easier to talk in the dual screen mode. So first of all, I want to say thank you so much for the nice introduction. And I actually had a page here to talk a little bit about. I'm losing my technology. Sorry about that. Excuse me. So I was actually going to tell you a little bit myself, but you did a very, very nice introduction, Lama. So thank you very much. So I'll spend this slide just to tell you a little bit about UL and what I do now in mobility. I started my career working at OEMs and in the industry, but now I'm moving to UL. I'm working more on this on the safety side of things, and so I'm helping the industry deploy advanced technologies in a safe, secure, and sustainable way. And without further ado, I'll jump right into the agenda. I'm going to talk a little bit about ACES, and you may have heard that terminology in the news recently, but it stands for Autonomous, Connected, Electrified, and Shared Mobility. And it's dubbed a huge transformation that the automotive and mobility industry in general is going through. And there is lots of questions around the safety of this, and I put this this little news article on this slide because it kind of, I guess, points out where we're actually at. This to me seemed like it was just almost impossible. How can you miss a police trooper on the highway with lights blaring and everything? So it's really, I guess, a reminder that safety is very, very important in the deployment of these newer technologies. So there's a general belief in the industry that these four megatrends, as they call them, are very, very interdependent. And I'm also of that belief. I think that to achieve in the end goal of autonomy, you're going to need some big advances in connectivity to ensure that you're safe, and you're also probably going to have to electrify your fleets to get there. And electrification is a little bit farther along, in my opinion, than autonomy and connectivity, but still there's safety concerns in that either. So why do we believe that these megatrends are interdependent? Well, one reason is customer demand. Technology early adopters They want all of this in the same car. They want their car to be autonomous. They want to be connected to their car. They want to do with the car everything that they can do on their cell phones. And early adopters are usually very, very concerned with sustainability. It's pretty much proven that EVs are going to be less detrimental to our environment. So there's a lot of forces from the customer to have these technologies all on the same vehicle. It's also much easier to implement autonomous features on EVs. There's fewer moving pieces. I think that I heard that in a traditional internal combustion engine vehicle, there are over 700 parts related to the powertrain of the vehicle, where in EVs that comes down to just a couple dozen parts. So it's a much more simpler platform. Wireless charging seamlessly integrates with autonomy. So think about the car just going over a pad and charging when it needs to, and then taking off and picking up the next person. And electrification and connectivity together and autonomy extends the range. What I mean by range is how many miles you can drive on a charge. And that's a really big EV pain point. And self-driving technology, this is probably not as obvious, but it requires significant power to be able to input all of the lidars and radars and cameras that are needed in redundancy, and advancements in battery charge times, range, and reliability of these EVs will accelerate the speed at which we can eventually deploy autonomous vehicles. And this is like really important. Number 6 is a really important point to me in that I believe in order for us to deploy autonomous vehicles in a specific operational domain, there's going to have to be communication between the car and other cars, but there's also going to have to be communication between the vehicle, the stoplights, the infrastructure, even possibly the lines, demarcations on the road, because this will enable us to add another level of safety to the self-driving vehicles. So I put this slide in here just because I think it's absolutely amazing how this map, how many players there are in all aspects of the supply chain. So you have your traditional from before OEMs, you have all these new OEMs, you have tier 1 suppliers. The automotive industry refers to the suppliers that supply them full systems as tier 1, and then tier 2 and 3 are components and materials suppliers. But you're seeing a lot of new names on here, a lot of startups. With EVs, you now have to have infrastructure providers, and then is very interesting to I think everyone is all of the mobility as a service suppliers, and that it's not necessarily just moving people, but moving cargo, moving food, moving coronavirus tests, whatever it may be. And then there's on the bottom, put a little bit of information about the TIC industry. UL is considered part of the TIC industry, which is testing, inspection, and certification. And then the one really interesting thing that I want to point out on this slide is insurance providers are getting very, very involved with autonomous and electric vehicle technology and connectivity, because there's this question that's looming out there. If the car is driving itself and kills somebody or damages property, who is responsible for that? So who is the insurance provider going to insure? Are they insuring the OEM? Are they insuring the fleet operator? Does any liability still land upon the individuals? So there's a lot of questions out there, and they are jumping on the bandwagon to understand the technology and help the industry deploy it safely. So the one thing I want to do before I jump too much into autonomy, and I used some nomenclature out there earlier, level 4, level 5, operational domain, those type of kind of terms. But in the industry, the Society of Automotive Engineers have very clearly defined what is autonomy, and defined the levels. So level 0 is your car from 15 years ago. So there's no automation. It's the driver, the driver's responsible for everything. Most people nowadays have level 1 autonomy. So you might have a blind spot monitor, or you may have integrated cruise control on your vehicle. Level 2 is a little bit more. So in my car, I have a level 2 vehicle. On my car, I have what's called ACC, which is adaptive cruise control. And it will actually watch the car in front of me and slow up and move forward. So many of you probably may have that on your car also. So level 3 is when the autopilot. Think of level 3 as Tesla's autopilot. So the driver can give up control to the vehicle, but he's must be able to take control if something goes wrong. And so that's kind of, I think, where we're at with the testing right now. I doubt if any level 3 vehicles will really be released to the general public, but I guess Tesla did. So there's one. And then level 4 is where I believe we're moving to as an industry and as across the globe. And that is that the vehicle is capable of performing all the driving functions under certain conditions, and it's termed an ODD, so an operational domain. So I'm going to give you an example of this. Let's say you're in a hospital or a campus. Let's say you're in a campus setting, and you would have a specific route that would move people around the campus that would be fully automated, but that vehicle can't go anywhere else except in that circle or in the particular paths that's defined for it. And level 5 is full autonomy. That's full autonomy we're a long way from full autonomy in my opinion. I mean, there are some people in the industry that thinks that we'll get there quicker, but I just think that it's probably not going to be in my lifetime. The technology isn't even there with respect to weather. Think about when you're driving your vehicle in Chicago snow. At least my car, all of the automation turns off immediately as soon as their flash gets on the cameras and stuff. So we're a ways away from there. And this is Frost & Sullivan's kind of a major consulting firm, and they also expect that L4 to go up fairly quickly throughout the 2020s years and be very prevalent by 2030. Level 3 is going to go down, and they haven't even mapped level 5 yet. So this is an interesting slide that I like to talk to kind of really give an idea of the complexity of what we're looking at. Level 5 autonomy is expected to have up to 1 billion lines of code. If you compare that against Facebook, which has 60 million lines of code, or a fighter jet, that's another one's got 20 million lines of code. You're talking about 1 billion lines of code. So the complexity of full autonomy is mind-boggling. this is just a tiny little bit of background on how autonomy works in a very, very simple sense. So most of the industry thinks of autonomy as sensing, thinking, and acting. So there's all of this technology on the vehicle that's taking in its surroundings. There's radar, cameras, LiDAR, ultrasonic, and there's usually a combination of all of these technologies together. Now, once all of the input comes in, there has to be some central computer or some central area that takes in all the information and says, okay, all the cameras and radars, they all say there's a little child in front of me. So I have to tell the mechanical parts of the car to stop. I have to send a message to the braking system and say stop because there's a child in front of the car. And so that's the act part. So you'll still have your basic car in functionality, but there's this pre-sensing and thinking that goes into it ahead of the time. So this just gives you kind of a little bit of background on how many sensing modules are going to be in a vehicle, and definitely level 4, level 5. There are maybe 10 radars, 8 cameras, and also ultrasonic and LiDAR modules also. And this represents a lot of cost. So I guess this is, I put together this presentation in sections, and this is kind of the end of the autonomy section. And I guess the big point here is, we're going to get there. It's just very, very early, and there's a lot of safety concerns that are happening, and it's very, very expensive to come up with this technology, which is, you can see in the industry, there's all different types of partnerships and acquisitions and consolidations and mergers are happening all over the place. Major car companies are buying small startups. Major car companies are partnering with each other. Major tech companies are partnering with each other. So there's just a lot of shuffling around going because they do know how expensive it's going to be to eventually get there. So what I'm going to do right now is I'm just going to stop. Oops, I'm going to stop after that section and see if there's any questions you have about autonomy. You can, I guess, raise your hand.
Yes, I think we have Professor Ramez.
Yeah, hi Mary. Thanks for the presentation so far. This was quite interesting overview. I guess my question is pretty simple. Is our infrastructure ready for autonomy? Because I'm just thinking about, for example, you mentioned Detroit and Chicago. Those are two cities that have massive problems with potholes in the winter, and vehicles usually have to, which I'm sure you're familiar with, vehicles usually have to swerve around to avoid those, to avoid doing damage to their suspensions and things like that. But autonomous vehicles, as far as I know, there's nothing out there anywhere close to market that can actually detect those things or avoid them in any meaningful way. How prepared are we for that?
Oh, yeah, I think that you're absolutely correct. I mean, potholes are a really good example. I mean, yeah, if I get hit, if I don't swerve around it and I hit the pothole, at times the cameras in my Honda will, dip after you go the pothole, and it'll emergency brake. It'll start braking because it thought the road was actually something in front of it. And so, yeah, we're definitely not, ready to deploy. But we are going to see more and more operational domain deployments, and what I mean by that is, hospitals, retirement homes, where they're retirement communities, I should say, beach communities, where they have, first of all, they don't have weather like we do in Chicago and Detroit, but they also have, they can build up that infrastructure that's needed for that particular place and deploy. We're working with a large major company right now that is deploying, actually deploying municipalities. So they're a big, huge builder that is now getting interested in autonomous vehicles. And they are working with municipalities to get everything set up properly. And Google has a spin-off company called Cabnu, and they are actually building in Detroit. So they're building a autonomous corridor from downtown Detroit to Ann Arbor, which is about 35 miles. But it will be specific. It'll have all the infrastructure, all the perfect lines, no potholes, all of the communication networks and ability to communicate with the vehicle. So there are things happening, but like it's not going to be anytime soon that we're going to see them whizzing across 94 from Detroit to Chicago.
Great, thanks.
I'm going to check. Am I still sharing my screen? Oh yeah, I am.
Yes.
Okay. Okay, so my next section, at first, were there any other questions?
Well, sorry to interrupt, but I have a very small question myself. So I was really interested when you said that the insurance companies are debating who to blame for the, if there's an accident or something. Do you know which approach is being the most, which kind of thinking is being proposed at the moment?
So there's a lot of talk, within the industry is with insurance is who are they going to turn to say, is this GM car safer than this NIO car or whatever, Amazon Scout or whatever? There has to be put forth a kind of test or framework or safety case that needs to be evaluated, at least I think, by a third party or maybe by the insurance agency if they can get the capabilities in there in order to say what is the risk of insuring this particular vehicle. And then there's also that not just insurance agencies, but municipalities, right? If the governor of Greenville, South Carolina wants to deploy autonomous vehicles, how does he know which ones are safe that are going to work in his operational domain? So there's all these frameworks that are being put together to try to understand how safe is safe and which is safer than another one. But the insurance agencies are really having a hard time because I think we just don't know what we don't know, right? But right now, any type of autonomous vehicles that are out there that are level 4 being tested or even in operational domain, it's the manufacturer's responsibility. They're insuring, if they are insuring the manufacturer. I don't know who else you could right now. Right. So in other words, when Google or when Uber had the accident in Arizona, it was deemed, well, I guess it was deemed both's fault. It was deemed the driver that was supposed to be watching, right? And but Uber took the brunt of it. Did that answer your question?
Yes, thank you.
Okay. Okay, I'll just jump really quick into electrification. And I think that this is, the electrification of America and of the globe is going to, it's going to speed up. We're seeing more and more cars get longer and longer ranges and more regulations around the world. But the main reasons that we want to move to electrification is first, global warming, our environment. It's pretty well accepted that CO2 is said to be the major driver for global warming. And on that note, I do want to say that when I speak about these trends, these ACES trends, I try really hard to speak of them in terms of mobility and not just automotive, because we're seeing the kind of secondary industries, or the entire transportation industry, moving towards electrification. That includes heavy duty, off-road, agriculture. You're seeing more and more e-bikes out there, sidewalk delivery systems, and so forth. And they're all moving in the same direction, and that's towards ACES. And the E part of it's very, very important for our globe. And then also too, we're running out of crude oil, but I guess most importantly, to make the OEMs jump and the rest of the industry jump is the regulations. So the regulators are transforming to stricter emission requirements. Now, when we had the previous Trump actually reversed some of our emissions requirements during his time in the White House, but that is moving back. Biden's turning them back very much stricter. So I think this is an interesting slide because it's not just the United States, and the United States is moving in that direction, but they're not, they're not leading. All of the CO2, all of the major countries in the world are moving towards electrification. So this is kind of a little bit of a different slide, but saying the same point. So you can see China's leading the charge in electrification, and if you've ever visited China, you probably can understand why. It's very, very crowded in the cities, and there's a lot of problems with air pollution because of the large amount of condensed area that people live in. So they're moving even faster than us, and Europe is moving faster too. It's with the regulations and so forth. And one of these things, a few of the things that I wanted to just mention with respect to how is this growth being driven? It's basically battery technology is getting better and better and better by the year, and more countries and municipalities and states and DOT, and even like IDOT, Illinois DOT, they're all starting to put more and more infrastructure. It's not just Tesla and the fast chargers anymore. There's more and more charging infrastructure. There's so many new models coming out in EVs, and with the improvement of batteries, the pricing is dropping also, and the range is getting longer. So I don't know how many people on this call have considered purchasing an EV, but I can pretty much assure you that my car will be an EV. The next car will be an EV. So it's a pretty colorful chart, but it's just a really short message on this chart. Is you can see the green, which is gasoline, it's declining. And you can see that all different types of electrification, and also diesel is declining, the brown is declining, and all different types of electrified vehicles are increasing. With the blue those are full electric vehicles, and then the light blue, which isn't growing nearly as fast, those are plug-in hybrid electric vehicles. So they have an engine in there also, but they also have a battery, and you can plug in and charge that. And then the orange is hybrid vehicles that are not plugged in. So in other words, it's a hybrid that doesn't need to be charged, but gets the energy from regenerative braking and other ways to recharge the battery. And then the yellow here is mild hybrid, and those are what's called 48 volts. So it has a full engine. It just saves a lot of emissions from using the battery on starting and other events that are highly emission reactive, I guess is the way to say it. So this is a really, really busy slide. And I think I'm just not going to spend too much time on this just to save time. But you can see it covers all different types of covers the plug-in and the battery, and talks about battery capacity, the range, and the very different types of chemistries and so forth. And so these are, I really like these maps of the landscape, because it just shows you how much it's changing. If you think about, like, back when I started my career, you know, there were, I mean, the only automotive companies that you thought of or you heard of was GM, Ford, and Chrysler. You know, it was a very, very different world. Now you can't even put all the logos on the map, and there's so many startups in this space, you know. So it's pretty interesting how everybody's kind of jumping on this bandwagon. Very exciting industry to be in right now. So this was an interview that KPMG, another consulting firm, had done on what people think is the most important challenge for e-mobility. It would be kind of cool if we could have a vote on Zoom to see what you guys think. But in general, costs were the biggest deal. Now we're taking that challenge away by getting more and more having the capabilities of the battery cost less and less. And 28% said it's electric grid and charging infrastructure. My personal opinion is we're still going to have grid problems. We're going to, even once we get the charging infrastructure up, there are places in the world, particularly in Europe and California, probably not in the Midwest, but there will still be some grid problems. And 25% said regulatory environment, that's going away too. 18% said CO2. So just I find this pretty interesting, and I find it interesting how different parts of the world react to the same question. And I think I'm going to skip this also, but it just talks a little bit about just a really simple comparison between an ICE, which an ICE, it's an internal combustion engine, compared to a full electric vehicle. So I put all these things on here to show you how quickly we're going to start seeing electrification. So Volkswagen said it will invest $30 billion in electric vehicles. And one of the things that I thought was very interesting, and this is not an April Fool's joke, it is actually true. Volkswagen has changed the name of their US operation to Volkswagen, VOLTS wagon. So I just thought that was just very, very interesting. It really shows you, how much emphasis that's occurring in electrification, and even in heavy duty. So Cummins is really jumping into that also in the rest of the major players. And then this slide, I put down some problems, and you can see there's recalls, Hyundai, BMW, the NHTSA, the National Highway Traffic Safety Administration, is looking into reports of battery fires in Bolts, and everybody's heard about the Tesla battery fires. So there's this great initiative, and then all these problems. And so are we ready yet? I'll tell you my opinion. I think we are. I think that internal combustion engine cars blow up, and internal combustion engine cars have recalls. We just don't hear about them, because it's not exciting news, and it's not Tesla and so forth. So I think that we're ready to go mainstream on EVs. This is just, I talked a little bit about the declining price of the batteries, and this kind of shows you where we're at, and it's not going to stop. It's going down also. Okay, so what I'm going to do now is, if I can put the camera back on, I'm going to stop and just ask if there's any questions about electrification.
We have one question. Muhammad, can you unmute yourself?
Hello.
Hello.
Can you hear me?
Yes.
Yeah.
So I have a question about the sustainability of this technology when EVs, when it comes to the batteries and when it comes to the source of energy that's used to recharge these batteries. So we know that lithium-ion batteries, the mining process is very harmful for the environment, and the process of recycling the batteries also, it's not so easy. So with scaling up production of these batteries, is this a huge concern? Is this kind of negating the whole purpose of preserving the environment because they're not so recyclable, or the recycling process is not so easy? And also the energy required, the energy that's being used to recharge these batteries, is it coming from renewable sources like solar or wind, or is it coming from conventional fossil fuel power plants or coal or such sources?
Yeah, so your questions are really good, and I'm first going to state that my background is automotive, and it's not energy, and so I may not be as qualified to answer the question, but there are many conversations going on discussing what you were mentioned, and I'll start with some things that you all are doing. We are working with companies in order to find a path of reuse and recyclability for those batteries. And there's a lot of work being done right now on when the battery can no longer be used in a vehicle, to start using it as a stationary power source, because it's it can't be in a vehicle in a moving situation, and it's not strong enough to propel a vehicle, let's say, anymore, but it still can be used in a stationary capability. So there's a lot of work being done on that. There's a lot of work trying to understand recyclability. And then I think you had one other question in there, is the power, that power that's going to charge all these batteries. Is that going to be dirty power, or is that going to be clean? I saw a study once that said that, in a state like Pennsylvania, where all the power comes from coal, that it's just better to stay in gas vehicles, as far as the overall benefit to the environment. But that is changing. There's a combination of renewable energies that are being investigated in to create the power for this. And, like I said, we're going to have grid problems. So there's going to have to be quite a bit of investigation into that. So hopefully I answered that, and I tried to not step too much out of my expertise zone there.
Yes, thank you.
We also have a question from Sichi. Sichi, you can go ahead.
Yes. First, thank you for this very interesting presentation. I have a quick question regarding the there are two main directions to do this electrification. One is like starting the entire car model platform from scratch, like I guess what Tesla has been doing. Another way is to kind of retrofit the existing internal combustion vehicle model, like what I guess that's most of the traditional car manufacturers has been doing. I mean, in my own opinion, the first way is maybe a better way, but these traditional car manufacturers, they surely have much more experience than these new car companies. So my question is, like, in your opinion, which way will kind of take an edge in producing more robust, more reliable electrified cars?
I might be a little biased on this answer, just because I spent so much time in the automotive industry, and I understand their testing capabilities, their responsibility to their brand, and their caution in moving forward. I'll use this as an example. There's regulations in the United States on what you have to test your battery to. So NHTSA says you have to crash it and smash it and drop it and have salt spray on it and puncture it, and it can't it can't start on fire. And that's the regulation. It's a great regulation, and even even all countries have those, right? But the automotive companies don't accept that. So if you want to supply an automotive company a battery, you have to cycle it in an environmentally challenged conditions, and rapid cycle even, and to road conditions for 150,000 miles, because they've gone through recalls. They understand what recalls mean, and they're slow. And yeah, I get it. It's easy to make fun of them because they're so slow, and they're watching Tesla beat them.
Yes.
But they have been burnt so many times by so many recalls, and that's the reason behind the caution. So my opinion on, Tesla seems like they're going to make it. Some of these other smaller startup EVs, we'll see they come up, they go down, they come up, go down. Lordstown is saying that they're 2 years away from anything. So some will survive. They always do, but not all of them.
Yeah. Thank you.
I see no more questions.
Okay. Okay, finally, well, not finally, there's a lot more on the deck, but probably the last topic we'll be able to cover is connectivity. And I'm particularly excited about connectivity because I believe that it's going to be a fantastic ability to make things safer when we can get the infrastructure going and have solutions. First, we got to figure out, whether we're going to use 5G or whatever, what range we're going to use. First, we got to figure that out. But there's just so much opportunity. But with this opportunity, probably comes a risk far greater than even batteries blowing up. And that risk is cyber. So if you have a connected car on the road that's connected to both your cell phone and the street lamps and the car in front of it, and then gets connected up to charge, to our grid, to our national grid, and then it additionally is hooked up because you're paying with your smartphone, hooked up to your banking system. Can you just imagine the havoc of cyber security hack into that? Now it's not just a car; it has a pathway into our national grid, into our banking system, into other vehicles that communicate with this car on the road. So to me, connectivity offers phenomenal opportunity, but it also brings with it some risks like I don't think we've ever seen before. But on the flip side, it's economically going to definitely bring a lot of growth into the industry. You can see these numbers are huge. The passenger car market expected to reach 75 billion by 2023. These huge CAGR growths in this particular area. So this is, I probably should have put this slide first because it kind of visually shows you everything that a car can connect to. So there's a lot of work and applications being done where vehicles can actually communicate with pedestrians, through the cell phone that they're carrying. I mentioned a little bit about vehicle to vehicle communication. And V2X is just the overall overriding all of these. Vehicle to device, so in other words, sensors, cameras, or whatever, and then vehicle to infrastructure, buildings, signs, lanes, and so forth. So, and then V2N, that's vehicle to network. And there's a kind of another addition to vehicle to network, and it's called OTA, which is over the air updates. And this is also getting to be a very, very big focus area for all of the OEMs. In order to explain what that is, it's kind of like, if you think about it, if Apple has a new version of software that they need to install on your iPhone, it just does it at night when it's plugged in, and it's over with. It's almost imperceivable to you when an update is actually made, unless there's an error in the update, which of course sometimes that happens. But that is where the automotive industry is going to also. There's so much code in the cars now. Think about that code moving to 1 billion lines of code. It's unreasonable to continue down the path where you have to take your car to the dealership to get a software update. So everybody's moving to over-the-air updates, but once again, with all of this connectivity, even in the OTA area, cybersecurity is a huge, huge concern. So the, as I mentioned earlier, the safety is very, very, is a very big outcome from V2X. And I'm excited to see what it can do. Here's some different scenarios that can be handled from V2V, vehicle to vehicle communication. I mentioned a little bit earlier about the over-the-air updates, and this is a little bit of a depiction of how that would work. So when you drove into your house and it actually discovered that it knows your network, it knows your Wi-Fi network, it could update over the air in the evening. And once again, I put my little map of what's out there, and you can see that there's a lot of different players coming in, fleet operators, telematic, logistics, distribution, car sharing. So many players are coming, are getting involved in connectivity aspects of mobility. Okay, so that is, I went through that fast because I do want to make sure that I'm supposed to give you 20 minutes, but I wanted to make sure I at least give you 10 minutes for any questions on that.
I think we have a question from Angeli.
Hi, Mary. It's great to see you.
Very nice to meet you. Talked to Angela on the phone a number of times.
Yeah, thank you again for the nice presentation. So my question is, in your experience and your outlook, I'm really, particularly interested in the transition with safety protocols, right? And even with the nice technologies you've shown. So for instance, maybe the level of automation allowed, the infrastructure built in within, say, adjacent states will be different. And then there will be a platoon passing, and then even extending to a mixed mode of traffic with, say level 5 and all the way to non-automated vehicles. So what is your outlook in this transition zone for protocols?
Yeah, I have in the back of this deck, I have a little bit of interesting information on how the, I can't get it to, let me stop the share. A little bit of information, and I can share the deck on how some of that's going to work, especially in the area of platooning, because that's going to come out fairly soon. And there's a couple of different approaches to that. So you are correct. It's not just going to be state by state. It's going to be municipality by municipality, because they're going to have to ensure that they're set up and the routes that these vehicles will take are going to be government designated, by a municipality. So there'll be very differences, but the highways are going to be handled different. And so there's lots of research being done on this, but they're actually looking at like various ways where, for example, the goods are taken to like a platoon station, and driven there from the warehouse to this platoon station that's kind of on the side of the highway. And as soon as the 5 trucks that are going to platoon together all get there, then the drivers go home and the one lead truck driver gets on the road and they can go across state or whatever, with the other trucks following them. So that's one way of how they plan to implement, platooning. I mean, that takes coordination across state lines, but not as much coordination as if like, it was autonomous passenger vehicles that are, crossing from Indiana. Let's say Indiana allows passenger cars to be on the roads, but Illinois doesn't. And so as soon as it crosses, it has to stop or it hits the state line. So we're not going to see that yet. That's going to be really, like I said, operational domain. But where you are going to see kind of broadly accepted rules for, let's say, freight transport and so forth.
Thank you.
Yeah, I did have yeah, so I can send this. Oh, jeez. Yeah, is my screen still sharing?
No.
Oh, sorry about that. Yeah, I'm gonna pull it up. So, oops. So, am I sharing now?
No, not yet.
Oh, I forgot to hit the share button. Okay, there you go.
Yes.
Yeah. So this is kind of what I was describing, various ways that they're going to actually end up applying platooning autopilot. This is the highway exit to exit. I think will be the first. But in the back, I'll share this deck. But in the back of the deck, it really talks about how heavy duty is handling these ACES technology changes.
Yeah, that'd be great. Thank you, Mary.
Yeah. Any other questions?
I'm looking. Well, I had some requests in the chat about the slides. So maybe they can email you and ask about these slides.
Sure. Absolutely.
And I think we have a few more minutes if somebody has a question. I mean, me myself, I'm pretty sure everyone here also is interested in the IACT. I mean, you presented many technologies, and we are curious maybe to hear which technologies are planned to be applied in the IACT.
Oh, I'll let Professor kind of jump into that question.
I think we have been working with Mary on this. We put a proposal together actually, and I can maybe share with everybody, including Mary, that we are just about to sign a contract for people to do a design on this, at least what we call it, an alternative initial design for this. And at that time, we're going to be going back and ask the stakeholders to provide, including, of course, Mary, about what are the technologies that we're going to be using. Meanwhile, we have our research team looking into electrification, looking into energy harvesting, looking into 5G, and how we're going to be implementing this as part of the IACT. But more exciting also, we did award 8 projects recently. They are small projects for new technologies that will be implemented at the IACT. I mean, they have to be connected to the IACT, and actually that was just 2 weeks ago when we awarded this. So maybe Mary, we need to reconnect again and tell you where we are at this time.
That would be awesome. And we also like to share some of the different initiatives I did that we've been working on. I did mention a few. We're working with Google on CAVNU, which is that corridor in Detroit. And right. We've got some probably things to share. We're working with Singapore, their autonomous vehicle track out there now. So there's lots of all these great initiatives.
Yamfing, I saw Yamfing here on the call, and Gassan is in the call, I guess. I don't know who else, but there is a team of us here who submitted also a proposal to Singapore just for collaboration between the 2 universities. Just a week ago, actually. Yep.
So ARTC? No, what is the name of the university again? They're very involved.
Yes.
Very, very, very.
Yep.
That's awesome news. That's really, really good news.
Yep. I thought I saw Yamfing on this, but yeah, he's still on. So he's leading this effort.
Oh, absolutely wonderful to hear.
Yep. And Gaston is here. Yeah.
Yeah, I mean, it's a proposal, 10-year project, collaborating with 2 universities at Singapore. And the overall overarching theme is automation of freight and mobility, particularly for connecting ports to land transport, looking at drones, looking at marine transport, looking at the infrastructure, to automate basically freight movement throughout the country.
Yeah. Awesome. Yeah, I know they're moving very quickly on that. They're probably from, I guess, my reading and the rankings by one, I forgot which consulting agency, they're #1 in the world as far as is their path to autonomy. So lots of good work with the Land Transport Authority and the university and ARTC all working together. And we're seeing that all over the world, Doug, working on some projects in Germany and California here in the United States. So we'll get there.
We'll get
there. Yeah.
Yep.
Well, thank you so much for your time. Thank you so much for the amazing presentation. And for everyone who missed part of it or some of it, or all of it, there is a YouTube link where you can watch this webinar again. And thank you again, Mary. It was wonderful to have you.
Thank you all. Thank you very much. You guys have a great holiday weekend too.
We'll talk to you soon.